Hi, I'm Jacobin, and let me tell you a story about a situation that occurred during a strategy workshop at one of our mining clients. We were all there to discuss some specific aspects about the mine where we had the workshop when we met some managers from a nearby mining operation. They were considering moving some of their production to an existing pit nearby and were wondering how much of their existing fleet would be needed in order to meet their 500,000 tons per month target. We told them how MineTwin would be able to assist them in answering this question. But as they were leaving for the coffee break, I could hear the one manager saying to the other manager, "I don't think simulation is the answer to our problem, and our mine is different." So this left me with a challenge. Would we have enough time during the coffee break to create a simple enough model to convince them that simulation is in fact the right tool for the job? There was not enough time for a formal data import. We did not have the full mine layout or a mine model. We only had some basic understanding of the operations, some initial assumptions, and a rough layout of the new pit as it was part of the strategic discussions. And with that said, I opened up MineTwin, loaded up the layout, and started the clock. Now, when we open up MineTwin, we make use of the scenario wizard in order to quickly set up a 1-month scenario. We leave most of the default settings as is. We quickly create two kinds of ore, one is for ore and the other one is for waste, and we assign it to production and development respectively. We also create two material types, for example copper and empty rock, and allocate these as well. We also set up our shifts automatically using the wizard, a 2-shift system with a 30-minute changeover period. Now we go to import our DXF layout. MineTwin is able to import various kinds of DXFs, and in this case we're going to use the topography. We can change the transparency as well as the color. Now normally we would import roads using the DXF functionality, but since this data is not available and we don't have the time, we're going to make use of MineTwin's manual drawing mode. We can quickly start drawing by simply left-clicking where we want the arc bend points to be, and we span the view by using the right-click. The problem with this, however, is that our entire road network will be drawn on the 0 coordinates, and we can quickly change this by using the elevation to surface. And if we have a look now, we will see that our z coordinates of the nodes is at the same height as the surface. We quickly start by drawing the additional roads, where we will have our garage at the top and our waste dump on the left hand side. The annotation tools in MineTwin is great for showing visually what you've drawn. Now we do a quick reachability check to make sure that everything's well connected, and we see that we've missed a piece. We can quickly create a mine node, reconnect our mine arcs, and make sure that everything is now reachable and connected. We do a quick check using the scenario check, and we see that we've got a piece of road that's got a degree of higher than 45 degrees. And that's just because our last mine node doesn't have the same z coordinates, and so we can quickly manually fix that, resolving the error. The last step is to set the correct distance of the route to the waste dump, which is actually 5 kilometers, so we can use the virtual length and we do not need to set this according to the scale. Now we can quickly check how our model appears in 3D view, and we can see that everything is mapped correctly to the surface. At this point, about 5 minutes into the coffee break, the scenario was looking like something the mine team would recognize, but a map is still just a map. To change their minds, I needed more. I needed equipment, I needed tons, I needed a production target. So the first step was to add a block to our pit. So we go inside the route, we add a node. We can now use the block tool to create a block for that piece of mine arc. We can change the direction, and now we can set up the block. We set up the ore type to waste. We add the advancement type, we set it to block. Then we can set the initial state to haulage, add the amount of ore that's available to haul, and set the length to the entire stope length. Now we add the materials using the wizard. We set it all as 100% rock. Next up, we want to draw some additional blocks inside the pit, which is very easily done using the drawing tool. And then once we've set those new blocks using the block tool, we don't need to set up the same parameters again. We can just copy it from the previous block using the apply pattern tool. This saves a significant amount of time when creating scenarios manually. We do a quick check and we see that we are still missing a dumping area. We add a dumping object from the left-hand side of the editor. We check all the characteristics. We ensure that the material allowed to dump there is both ore and waste. We look at the general parameters, and we now add the inbound node, the location where trucks would dump the material. Next up, we need a target, so we're setting a development target of 500,000 tons for this month. Next up, we need to set up some trucks, so we look at the library of existing truck types, and we choose the Caterpillar 775G. Next up, we choose an excavator type. We're going to choose one of the Hitachis. All the equipment pieces inside MineTwin comes preloaded with their standard characteristics, Next, we add one of the trucks. We choose the home location to be the garage. We change the truck type to the unit that we've just selected. We add our excavator, set it inside the pit, and also choose the excavator type. If we do a quick check, we see that everything is fine, and we can now start running the simulation. There's handy pop-ups inside MineTwin to show you the detail of what every piece of equipment is doing and some key performance statistics. We can see the truck moving around from the dump area to the excavator being loaded. We can also view the model in 3D to make sure that everything is moving around correctly. So what's key to know about MineTwin is it does all the scheduling and coordination for you. We can see that a loading task has been scheduled for the excavator and a haulage task for the truck. And these tasks get converted into the actual movement and actual operations of the different pieces of equipment. So we can see when we finished running the model that we got to about 126,000 tons for the month, where our target was 500,000. So we most likely need a bit more trucks. And we can simply copy and paste the existing trucks inside the equipment unit setup. So we can see now with the 5 truck, there's a lot more queuing. We can see that we've reached the target of 500,000 tons, and we can view detailed statistics of the simulation. By the time the team started returning from their coffee break, the model was already running. They could see on the screen their operations, their trucks moving material from their pit along a route that they recognized, and something changed. They weren't asking whether the simulation could accurately represent their mine anymore. They were asking what the model can do for them. Then one of the managers looked at the model and asked the question every consultant wants to hear: what if? What if we used our larger trucks? So we immediately saved the scenario with a new name called Alternative Truck Fleet, where we can now make the changes to our truck types. We add a new truck type to our scenario. This time we choose the slightly larger Hitachi. We go to our truck units, where we change the type of the first one and then apply this characteristic to all the trucks in our fleet. And we also disable the 5th truck to run now with only 4 trucks. We can see that we still managed to keep the target of 500,000 tons, and that truck utilization is now less than 80%. Now, the point of the story is not that we managed to complete a fully engineered, calibrated model during a coffee break, because we did not. A final operational or investment decision would still require accurate site data, verification and validation, and more detailed analysis. The point of the story is that during a single coffee break, we managed to test the question, expose the important assumptions, and identify the parts that needed further investigation. More importantly, the conversation changed. It moved from simulation is not the right tool, our mine is different, to what else can the model do for us? What more value can we gain? Every mine is different, and this is not an argument against simulation. This is an argument for having a model that is truly flexible and can be adapted quickly to answer any kind of question. And this is exactly what MineTwin aims to do with its manual scenario building capabilities. Thank you so much for watching. If you're interested and want to know more, please visit the website where you can contact us or download your free trial of MineTwin. In a future video, we'll be showing you how to use studies functionality in order to automate some of these analysis and scenario comparisons. Thank you so much.